Okay, let's look at an iterated integral. We're beginning our work with multiple integration, and we begin by just exercising a strategy called integration by iteration. Right now, it's just a formal way to do integrals, and we don't really know the connection that it's going to have, but that's usually how calculus works out for us. So what we notice here is we have what appears to be two integrals. We have a function of xy, 2y e to the negative x, and we have dy dx. Now with our iterated integral technique, the dy, which is the leftmost differential, we integrate first, and then dx, which is the rightmost differential, we integrate second. So we look at this particular function of x and y and integrate with respect to y. Of course, anything x or constant has no bearing, and so we can just kind of pull those to the left. We integrate y with respect to itself, and we get y squared over 2. Of course, the 2 is already there. Those will absorb. And then we apply the fundamental theorem of calculus to the y variable. So again, we substitute square root of x here, square it, and we also substitute 1, take the difference. And when we simplify this, squaring the principal square root and squaring 1, we just get x minus 1. Now at this point, you can guess an antiderivative, or you can just use integration by parts. And of course, we can do the Heaviside method because this is a very simple integrand. We always organize our integration by parts so that we get our signs correct. So of course, we're going to differentiate x minus 1, and we're going to integrate or anti-differentiate e to the negative x. And this is very easily done. Of course, the nice part about the polynomial is that it differentiates to 0. And now following the theorem for integration by parts and noting the alternation in sign, as we multiply here, we get a negative e to the negative x times x minus 1 minus an e to the negative x. And then again, using the fundamental theorem of calculus, we must evaluate upper limit 4, lower limit 2. Now, one thing you notice here, if you had guessed an antiderivative, you would think this would be somewhat elaborate, and it is. You can see here that the negative x e to the negative x is the only surviving term, because here we have the negative negative, which is just the additive inverse of this term here. So those two, the outer terms absorb, so to speak, and we're left with the negative x e to the negative x. And then just apply the fundamental theorem of calculus, upper limit of 4, lower limit of 2, the minus minus will give us the plus here, and then if you will, you can just retire your answer or your actual response, getting rid of the negative powers if you like. Certainly not required, but we always like our responses to look nice. Now, just as another thing to mention about this problem, the region of integration is very easily seen here by our technique. So when we look at the y variable, we see that y exists between 1 and the square root of x, which we write as the first line. And then as we move out, we see that x exists between a lower limit 2 and an upper limit 4, and we write here. So basically, we're looking at this region as x being independent and y being dependent as it depends on x. And we are done.